Alright, so this is the video that we're going to do part 2, so we're on the other side, so now we have 9 through 14. So number 9, we're expanding the logarithm fully using the properties of log, so we want to get it back to log x and just log y by themselves. So this is remembering that if they have the base and they're being multiplied, they're actually being added, right? However, okay, log x, this is exactly how it needs to be. So log x stays the same. However, this log y to the third needs to be simplified again because we can't have that exponent there. So we're going to move that over here, and we have 3 log y. And this is what they're wanting. They want that log x and log y instead of that y to the third. So this is all we're kind of doing. These are just practices to remember these kind of solutions and what equals what when you're using logs. Similar to number 10, they want you to see what are you doing when a log is being divided. Well, you're actually subtracting these two, right? So you have a log z to the 4th times x to the 4th cubed minus log y. So we have those are our 2 logs, right? But log y stays the same. We're kind of done with him. You can't really do anything else to get them back to, you've got them back to the log y. Now we need to work with the first one. This is the same thing as, do you see they're being multiplied? So we actually have a log z to the 4th plus log cube root of x to the 4th minus log y. So again, we can move that 4, right, go in the front of this log, stays log z. So now we have the log z they're wanting. We have this log y they're wanting, right? Only thing left is we need to move this kind of solution here. If we remember, x to the 4th cube root actually equals, right? This actually equals x to the 4/3, which I'm not going to go over in this video just because we should kind of already have that memorized. If you do need to look over that, you can go through your notes or get some practice from online, or let me know and I can get some resources. So this is where we kind of get, so we're done with this. We now have this. We're going to move that to the front. Leaves us a 4/3 log x. So now we have the log z they want, the log x they want, and this kind of wonky log y over there. So this is kind of what they want when you're putting it in terms of log z, log x, and log y. Alright, for number 11, they want you to start kind of plugging these in. You don't plug anything in yet. It all makes more sense, right? Because we need to get to these log A, log B, and log C. So how we do that, if you remember, right? If we're actually dividing, we're actually subtracting. So we have this, right? Again, this can be split up again. So we actually have log A to the 7th plus log b to the 8th minus log c to the 6th. Again, we're not at this yet, this log a. This a has a 7th, it's raised to the 7th power, so now we need to move all of these exponents to this front. So now we have 7 times the log of a plus 8 times the log of b minus, and then we have 6 log of c. So now we can actually plug in these values they give us. So log a actually equals, if you look above, actually equals 9. Log b equals 5. And log c equals -2. Now I'm not going to do the math to show you exactly steps, but you can enter this into a calculator, you should get 115. So key thing here is they want you to realize that you need to get it to this form before you can actually plug anything in. All right, number 12 is remembering this is what you can kind of enter into the calculator, right? So you can't really enter this into the calculator yet, but you can get it into a log. So our base is 2. Our answer, right, is 99. Or is our 99 goes there, and then our answer is x, right? Now you can enter this into your calculator, and by doing that, you should get x is about 6.6293. And it says nearest hundredth, so again, you can have your answer as 6.63. So here's they want you to see, you've been kind of going into this formula to solve. Now we want to go into this formula to solve, because this is the way we can enter it into our calculator. Which, if any of you need help entering into your calculator, please let me know. Through email or in class, I can help you with that. Alright, so for number 13. Number 13 is wanting you to, again, remember that formula. So if 4x is our base, 2 is what we're raising it to, and 4x plus 3 is our answer. So through here, we can kind of move this around, right? Because they want us to put it in the exponential equation. They want something squared, x squared, then x, and then a constant, right? So from here, this can be simplified to 16x squared, right? And then we move this over to here. Then we have minus 4x minus 3 equals 0. And that's all we have to do. They don't want you to solve for x or anything, but they want you to realize getting it into this form makes it easier to solve for x, because looking at this, that's really hard to figure out what x is. But if you look at this one, that's pretty much like factoring or using the quadratic formula that we've used before, and it's more easier to see. Alright, number 14 is our last problem. Here again, they want you to realize your formula that we have. If our 2 is the base and we're raising it to something, our answer is supposed to be this. 1 over the square root of 2 to the third. So what they want you to see here is we're going to take this, focus on this one side. This is the same as 2, 3 over 2, right? Now, if we remember something about negatives, negative something, when we raise a value to it, it's actually the reciprocal, right? If we take this out real quick, that's 1/2. That's the reciprocal of 2, right? So we know there's a negative. And all we need to do is see what our answer was. 3 over 2. So we know negative 3 over 2 is the reciprocal of 2, 3 over 2, if that makes sense. So yeah, that's just remembering that if it's 1 over something, it's actually the negative power. So that's where we get to the x equals this, and we obviously need to see that x equals negative 3 over 2. So here is something you need to remember. When you see this 1 over something, it's actually, that's the negative power. So whatever is being brought here will be moved to this spot. So I hope that makes sense. Here's the video, the last part. I will see you guys after break.